Hey everyone, and welcome back to the channel. We've got some major breaking news coming out of Starbase, Texas, and it's a bit of a mixed bag for SpaceX and the Starship program. Early Friday morning, the very first of the new and improved Block 3 Super Heavy boosters, known as Booster 18, suffered a pretty dramatic failure during ground testing. Now, if you're a space fan, you know that testing is a core part of the SpaceX philosophy. But this one was a real spectacle. Around 4 a.m. local time, during a routine pressure test, the lower section of this massive 70-meter-tall booster suddenly buckled and blew apart. Live stream cameras captured the whole thing as sudden crumpling, a cloud of gas and debris billowing out from the test stand. It was a powerful explosion, and honestly, pretty shocking to see. The most incredible part? The rest of the 20-story rocket actually remained standing, which is a testament to its overall structural integrity. But make no mistake, the damage is severe. Photos taken after the event show a huge, gaping hole in the liquid oxygen tank and significant structural damage to the aft section. So, what exactly happened here? SpaceX quickly confirmed the event, calling it an anomaly during gas system pressure testing. And here is the crucial safety information. They stressed that no propellant was loaded onto the booster at the time, and no Raptor engines were installed. Most importantly, all personnel were kept at a safe distance, so thankfully, no one was injured. This is a key part of their rapid testing approach: fail fast, learn fast, but always prioritize safety. Now, let's get into the nitty-gritty of the technical details. Early analysis, both from SpaceX and from the brilliant community of independent experts who watched these tests, points towards a failure of something called a composite overwrapped pressure vessel, or COPV for short. These are smaller tanks inside the booster that hold highly pressurized gas. It seems one of these vessels, located in one of the booster's chines, those fin-like structures at the base, failed. This failure likely set off a devastating chain reaction, which ultimately led to the main liquid oxygen tank rupturing under the immense pressure. It's like a small, critical component failing and causing a much larger, more catastrophic system failure. Why is this specific booster so important? Well, Booster 18 wasn't just any old prototype. It was the pioneer of the next generation of Starship, the first of the upgraded Block 3 or V3 design. These new boosters are supposed to be more robust, more efficient, and easier to manufacture. Booster 18 was slated to be the vehicle for the 12th Starship test flight and was also going to be instrumental in commissioning the brand new launch pad, Pad 2, at Starbase. So, losing it is a significant setback, not just for the next flight, but for the entire rollout of the new V3 architecture. What does this mean for the Starship timeline? With Booster 18 now almost certainly beyond repair for any future flight, we're looking at a delay. It's hard to say exactly how long, but analysts are predicting that the next test launch and the debut of this new Block 3 design will have to wait. The focus will now shift to the next booster in line, which is likely Booster 19. SpaceX will have to build it, transport it, and put it through the entire series of tests that Booster 18 was just beginning. This includes structural proof tests, cryo tests, and eventually, a full static fire with all its Raptor engines. This event really highlights SpaceX's philosophy of test, fly, fail, fix, repeat. Elon Musk has always said that if you're not having failures during testing, you're not pushing the boundaries hard enough. While a failure like this is never what you want to see, especially with such a beautiful piece of hardware, the data gathered from it is invaluable. Engineers will now be poring over every sensor reading, every frame of video, to understand exactly what went wrong with that pressure vessel. Was it a manufacturing defect? A design flaw? Did the pressure exceed its limits? Answering these questions will lead to stronger, more reliable boosters in the future. Think about the early days of the Falcon 9 program. They had their fair share of spectacular failures on the test stand and during landing attempts. Each one was a public lesson that ultimately led to the incredibly reliable and reusable rocket we see flying almost every week today. This is the same process, just on a much, much larger scale. Starship is the biggest and most complex rocket ever built, so the challenges are exponentially greater. The ultimate goal here is a fully and rapidly reusable super heavy lift launch system. This is the vehicle that's supposed to make the massive Starlink V3 satellites possible, send humans on deep space missions to Mars, and of course serve as the lunar lander for NASA's Artemis program, which aims to return astronauts to the moon. The stakes are incredibly high, and the pressure is on. This is why they push the hardware to its absolute limits on the ground, so they can find these weaknesses here on Earth, not 100 kilometers up in the atmosphere. So, while it's a tough day for the team at Starbase and a definite delay in the schedule, it's not the end of the world. It's a bump in the road, a very loud and explosive bump, but a bump nonetheless. The factory at Starbase is constantly churning out new rings, new domes, and new sections. The pace of production is one of SpaceX's biggest advantages. They can build a replacement booster much faster than any traditional aerospace company could even dream of. We can expect to see Booster 19 and maybe even Booster 20 rolling out and beginning their own test campaigns in the coming months. It will be fascinating to see what changes are implemented based on this failure. Will we see a redesign of the COPVs or how they are integrated into the structure? Will testing procedures be modified? These are the questions the entire space community will be watching closely. For now, the wreckage of Booster 18 stands as a powerful reminder of the immense forces involved in rocketry and the fine line between success and failure. It's a tough lesson, but one that will ultimately make the Starship system stronger, safer, and more capable of achieving its ambitious goals. We'll be keeping a very close eye on all the developments at Starbase, so make sure you're subscribed to the channel with notifications turned on. We'll bring you the latest news as soon as we get it, from the cleanup of Pad B to the rollout of the next booster in line. It's a setback, for sure, but the march to Mars continues. What are your thoughts on this? Does this change your perspective on the Starship timeline? Let me know down in the comments below. It's always great to hear your analysis and opinions. Thanks so much for watching, and we'll see you in the next one.